Okay, we're going to finally get to talking a little bit more about the weather in our latitude, the mid-latitudes. We are, as you saw in the global circulation, kind of in a transition area. We have the tropics to the south, the Arctic to the north. We have high pressure at 30 degrees north. We have low pressures that typically run around 60 degrees north. We're between them. So what does that mean for our weather? Well, first of all, let's talk about the air masses we deal with here. One of the interesting things is in the U.S., we get all kinds of air masses. And these air masses originate where their source region is how they're really named. Think about it, continental polar. Where is it at? It's in the continent of North America. It's dry because it's continental. It's polar because it originates over basically snow-covered ground most of the year up in Canada. Arctic air masses originated towards the North Pole. There's maritime polar air masses that come down off the ocean, but they're relatively cool. They're not as cold as continental air masses. And then you have more maritime tropical, typically down over around the 30-degree north area. And we also get continental tropical, which may form over the desert southwest, dry tropical air. Where these air masses collide, there are fronts. So the definition of a front is the contrasting between two air masses. So with that, air masses will modify as they move out of their source region. So cold air masses, when they move down into the United States, come in typically less snow cover. There's more heating of the ground. They're going to get warmer. Maritime tropical moving out of the tropics upwards into the United States is going to begin to dry out because it doesn't have as much moisture. And it might begin to cool off, especially if there happen to be some snow on the ground in the wintertime. So here you have a stationary front, two air masses hitting each other, and they're not moving. We have a cold air mass to the north with the cold air and a warm air mass to the south. We have learned that warm air is less dense and lighter than cold air. So if this is not moving anywhere, the cold air is going to stay settled on the ground. The warm air is going to tend to want to rise up and over. So when it's rising up, it's going to have clouds that form higher and higher because the warm air is actually getting higher and higher in the sky. Cold air is thicker the further north you get. So you start off with cirrus clouds. If you were driving south, you would see some cirrostratus, altostratus, nimbostratus, eventually raining clouds. And that would be the typical progression of clouds along a stationary front. The heaviest rain would be near the frontal boundary, the less rain, and probably not even any clouds the further north you get. Now, if you have a warm front, the simple thing with a warm front is the temperatures are going to warm as the front passes your place. So you might actually start off as a warm front's approaching you. Maybe you're living in the northern part of Ohio, and it's been bitter cold. And we have a low that's moving up to your west. It's pushing this warm air up. Remember, southeast of the low is warm advection. So you have the warm air coming northward, and you wind up with snow maybe at the beginning. But that warm air is getting thicker and thicker above you. So it's going to change. Remember that we looked at it in precipitation, where it changes over to rain or even freezing rain, depending on how the low levels of the air holds. So as that warm front passes you, temperatures are probably going to rise. Now, cold fronts. Remember, cold air is very dense, so it's going to be a steeper surface. It typically has more thunderstorm activity with it, sharper contrast in air masses. So you typically will have warm, all of a sudden, much colder when it goes through. And cold fronts can move down and warm fronts can move in all different directions. This is a depiction of what I hate. along the east coast of the United States, we get backdoor cold fronts. I do not like them because they bring down a lot of maritime polar air into the eastern part of the United States. Maritime coming off the water, and it's cool. So when these occur in the late spring and early summer, where I'll be looking forward to having a nice sunny day with temperatures in the low 80s, I'm getting winds coming off the North Atlantic. I'm getting a lot of clouds, and I'm getting temperatures in the 50s or even low 60s. Not the day I was looking for. And the cloud deck is not real thick. If you were to look at the Appalachian Mountains many times, you can climb up to the top of the mountains, maybe 3,000 feet up, not even 3,000. You may be above that cloud deck. So you can see all these clouds out to the east, and I'm sitting there not having a good day. However, you in Ohio might be on the other side of that front and having temperatures in the 80s. Occluded fronts. There's a cold occlusion and a warm occlusion. So let's take a look at occlusion. What happens is a cold front catches up, pushes through a warm front so that it lifts all the warm air above it. And there's another cool front or cold front that might have cold air mass that was out ahead of it. So cold occlusion, when the occluded front is moving towards your location, the air is colder from the direction where it's moving from to the direction where it's reaching. So in most cases, fronts move from west to east. The west would be colder, the east would be warmer. A warm occlusion is just the opposite. It has a little bit more, it's cool, but not as cold as the air mass it's replacing. Now, we're going to talk about extratropical cyclones. Extratropical cyclones are just low pressures. That's all they are. They're not related necessarily to tropical systems or anything like that. They occur all the time in your area. So this is the Norwegian cyclone model. What you have is cold air, and you have divergence that's occurring along a jet that's beginning to allow this surface low to develop. That's the very first indicator. You get a stronger divergence. That surface low continues to develop more and begins to form a comma head. You have a warm front out ahead of it and a cold front down along it. And eventually, here, that cold front has reached the warm front and began to push it out of the way. And the final stage is you have an occluded front there, where the coldest air is probably, in this case, to the west and cool air to the east. And you still have a warm front down here. So you literally have what we call a triple point, which is an occluded front to the north, a cold front to the south, and a warm front to the east. And many times new lows will begin to form in this area. So this is a typical Norwegian cyclone model. It's been around since the 1800s. And you can actually see here all of the patterns, how it goes through its waves, begins the occlusion, and finally strong occlusions. Now, there's another part to this called the conveyor belt model. This was developed by a professor friend at Penn State, Toby Carlson. And he looked at airstreams. And when he did that, he says, okay, there's a dry airstream that we know is on the backside of these highs coming down. So it rises and comes around the low pressure system, which is the low right in here. We know there's a warm conveyor belt coming up from the south, out ahead of the warm front, along the low. We also know to the north, there's probably a little bit of a high pressure up here and pulling in cool, very damp air coming off the ocean, called a cold conveyor belt. This cold conveyor belt then wraps back to the northeast with time. This is what forms the comma head. You've got a question about that. This cold conveyor belt comes in and turns anticyclonically back around the high, and it forms a comma head when it does this, which is why you see a typical comma head on low pressures. There are different kind of weather associated with extratropical cyclones, depending on where you are in relation to the center of the low. If the center of the low is passing by your location, you may, and you'll see it from pressure tendencies. Faster falling pressure will indicate the low is coming towards you. Rising pressure behind the low indicate where the low came from. There's a warm sector where temperatures are relatively mild, maybe a better chance of thunderstorms. Better more steady rain north of the warm front and up along just to the north of the low in the cold air. So you can see most of the snow is going to be, if you stay in the cold air, you're going to tend to be all snow. If you get into the warm sector, you tend to be more rain and maybe even some ice. Lows can form all different locations in the United States. Here is the Colorado low. Look at it, it's further south than the Alberta Clippers, which form further north. That Colorado low is much closer to the Atlantic and to the Gulf of Mexico. Great moisture source. It's going to tend to bring moisture up. And when they form and they move in, predicting exactly where they're going to go over your house at, what sector of that storm is you're going to be in, can be extremely difficult. So that can really mess up your forecast. Another thing about extratropical lows, the air gets colder aloft above them and the actual pressures drop significantly. Remember, cold air allows the pressures to drop faster in the vertical, so you wind up with lower pressure even aloft. And when they're weaker, you don't get quite as much drop, but you still get some kind of a trough to the north. There are warm core cyclones. I mentioned one last week in the monsoons. What happens in a tropical system is their warm core. What that means is the pressure doesn't drop as fast in the vertical, and you actually wind up with high pressure above them. So the warm core systems have their lowest pressure near the surface and higher pressure aloft. There are anticyclones, which are just highs, cold core anticyclones, or a warm core, depending on if they come out of the tropics or not. We also have regional circulations, lake and sea breezes. You get a lake breeze and or sea breeze off of Lake Erie, for example. Mountain and valley breezes. Think about it, how the air would circulate depending on the heating to where the sun shines. That dictates how the mountain valley breeze flows. Chinook winds happen out in the west all the time. They actually happen on the Appalachians. Sometimes you get a nice east wind running into the Appalachians and sinking down on the west side of them, clears them out, and the east side stays sunny. Or in the wintertime, strong west winds hit the Appalachians. They rise up and cause the snow, lake effect snow in the Appalachians. They sink down on the eastern side. What do? You get drying and a little bit warming. Many times that's why I don't get as cold at my house to the east of the Appalachians as you would to the west of them. The Chinook winds also are part of the Santa Ana winds when they're coming down slope. And remember, gravity will pull air down. It doesn't pull it horizontally, but it will pull it down towards the ground, towards the center of the earth. So if a slope is down slope, the gravity is going to accelerate the wind down. You get the adiabatic compression. You wind up with very hot, dry winds. Hubbobs are just dust storms. If you're in Arizona or New Mexico, in that part of the United States, sometimes you get thunderstorms that are generated, and these tend to have gusts that come down to the ground. However, most of the precipitation may have evaporated in the cloud. So you wind up with this gust of air coming down, pushes out the sand, causes a hubbub or dust storm. Heat bursts can occur from convection. I witnessed one firsthand in Oklahoma City once where it was very dry at the surface, but thunderstorms formed aloft, and through the adiabatic warming, dry adiabatic warming that thunderstorm had, because the rain never reached the ground, temperatures rose from the 70s into the 90s in Oklahoma City in the middle of the night. They cooled back off later, but that is what the heat burst is. So looking at this, here is the jet stream forecast. Not real powerful for later this week. This is actually Sunday. You can see here there's a little jet streak coming across towards Iowa. Left front quadrant, you would expect some lift. Much stronger, much deeper low, probably out over off the west coast of the United States. And this is the actual forecast. You can see very intense low out there. But there is still a low here. And this low has a warm front east of it and a cold front south of it. And this warm front is pushing through western Ohio and all right here. The pressure drops along the warm front. This is actually causing you to get some rain. I wanted to give you an idea of a calm ahead. Here you can actually see one very intense low up over just south of Alaska at this time. So I think that's about it. Let me know if you have any questions.